Oh, you're muted, Maddie.
Maddie, are you going to be the host afterwards? Are you going to be taking over the? Okay, so I'm going to make you the. Remind me to make you the host before I leave. I'm going to make you guys the co-host for now.
You can make Ish a co-host as well.
Yeah, I'm going to make Ish a co-host as well. Okay.
Yeah.
He doesn't deserve to be because I saved his butt. I'm just kidding. No, I'm just kidding. Okay, so, okay. All right. All right. Good seeing every one of you, right? Okay. Yeah, this is okay, kind of uneven, right? More female than a male athletes in here, right? Majority, yeah. Cool. All right. So, you know, I'm not complaining. Okay. So what you guys learn? So you watched the lecture video on Monday, right? Or some of you guys probably watched it on Tuesday. So what did you learn about the first lecture video? What is statistic all about? Anyone? MVP point.
Collecting information.
I just got here. All right.
Collecting information. Very good. So we want to figure out information, right, about certain, you know, subject or population, whatever it is, right? Okay. But collecting information is what? Or collecting data is very, very what? Messy, right? Okay, so the basic overview that I told you about in lecture number 1 or on Monday's lecture was that what we want to do is whatever we're trying to study or find information about, we're trying to find those information by collecting the data and analyzing that data. Okay, the word statistic represents what we call a sample data. Okay, statistic is a sample data. So we're basically analyzing a sample data. The reason why is that because when we're actually trying to figure out information about a population, suppose there was a question on module number 1. They said, okay, there were how many people who, how many men who actually what percent of men who actually likes color blue, right, in United States? In order to figure out that precise information, I want to figure out the proportion of men who actually like the color blue. What I need to do is I need to go out to the field and ask every single man in United States and then figure out their color preference. Is it feasible? Is it possible? Yes or no? You're like, no, hell no, right? Yeah, it's gonna take me like days, maybe even years to actually collect all those data, right? Okay, nearly impossible to do. So what do? I take samples, right? Probably take sample of some, you know, maybe about 100 people in California, 100 men in California. Take a random sample of 100 men in, you know, Texas, Arizona, New York, all these, right? I could do that. I could email 100 people here, 100 people there, and then get their preference, and then figure out, right, their, you know, proportion of how many men who actually like color blue. Right? And that is going to be representative of the population. And that's what we're trying to do. Okay? So that's the overall thing. So the first thing that we need to do, so as a statistician, you need to want to figure out, and you want to do an experiment, and you want to figure out, right, how many people who favor how many men who likes the color blue. What's the first thing that you need to do? We need to what? Collect the data, right? Krista, yeah, you got to unmute.
Oh, data, I said data.
Good, collect the data. And remember, in the first page of your module, data is very, very what?
Important.
Important, good. but more so very messy. Our raw data are very messy. So in module number 2, right? In module number 2, what we're trying to do is we're trying to organize our messy data. Okay? And there are several different ways to organize our messy data. And depends on if you're looking at a categorical data or numerical data, right? You organize it in different fashion. Okay, and there's different ways to actually organize, and we'll be going over those different ways to actually organize them. Okay, so now before I actually jump into our official lecture, because you went through all these module number 2 material, right? Do you have any question on your module number 2? Okay, so let me actually switch to module number 2 here. Angelica Gonzalez. Let me remind myself here. I'll just do that. Okay. All right. I need to erase a lot of these because I should. Any question about this right here? Okay. So here, so the learning objective, okay, you should have gone through all this right here. Okay, so the learning objective that we're going to be looking at here. So let me write something down here so I could get more page. Okay, so I can. Okay. All right, so here, okay, learning objective that we're going to be looking at, how to create use frequency table, how to create use two-way table, how to make use a bar graph, and how and why it is different from histogram, how to make use a pie chart, how to interpret other visualization of categorical data, how to interpret a dot plot, how to interpret a stem plot, right? Okay, or here, one way to actually organize your data, okay, is what we call the what? What is this right here? Frequency table, okay? Like they said over here, now that we are collected our data, we need to make it useful. Data is messy, typically raw data, right? So therefore, especially from survey comes from a spreadsheet or similar with errors and typos and misunderstood answers and all kinds of other problems. So therefore, what do we do with that raw, messy data? We need to what? Organize them. So you'll never see it. So as a statistician, you'll never see this as your first step. Okay? So far, so good. Okay, so this is actually the second step of organization. Module number 1 is collecting data. So, okay, looking at this right here, okay, looking at this frequency table here, what are we observing here? Okay, can someone identify our observational unit?
People who eat Skittles.
Excuse me?
Would it be people who eat Skittles?
People who eat Skittles. I think you went a little bit too specific, but you're right there. Very good. Skittles. Who was that?
Jasmine?
Jasmine. Good. Okay, so yes, it's just Skittles. Observational unit is Skittles. What will be your variable?
The colors?
Very good. The colors, they differ in colors. Red, orange, yellow, green, and purple. So far, so good. Okay, so your variables. Remember, there are 2 types of variable that we dealt with, module number 1. Okay. Okay, so there's 2 types of variable. Variable branches into what we call the categorical and what? Categorical and
Numerical.
Numerical. And there's two ways, there are two types of numerical. I won't discuss that right now. But of these two, categorical and numerical, let's go back to module number 2 here. What is this right here? Categorical or numerical? Variable. Okay, so a variable. What's your variable? What's the variable here? David said it, right? Was it David?
Yes, it was color.
Right. It was color. Is color numerical or categorical?
Categorical.
Categorical is the characteristics, right? Okay. So this is actually considered to be a categorical data frequency table. Categorical data frequency table here. So far, so good. Okay. So you need to know how to identify, just by looking at these tables, identify what is your observational unit, what is your variable, what type of variable you have, and so forth. So far, so good? Okay, and you'll never see it in this form right here in the beginning. Okay, so as a statistician, I'm curious about, what is the proportion of all these different colors? So what do? What's the first thing that you would do as a statistician if you want to actually figure out that information? You'll take a bag of not M&M, Skittles, I'm sorry. And what would you do? You will open them up, be logical, open them up, and then start taking out, and then what? Putting data. Take out one of your Skittles right here. Okay, and one came out to be what? One came out to be, the first one came out to be what? Red. The second one came out to be what? Orange. Third one came out to be what?
Green.
And this is basically what you would do. You would start taking out, right? For me, I would just dump it out, right? Dump it out and then just organize it, right? Okay, but this is what you would see as a raw data. You got, okay, red, orange, green. So you could have said, oh, red, orange, green, purple, and so forth. And then you will write this down, yellow, and so forth, right? So far, so good? Okay, but once you kind of, list them out like this, you would actually more so, you want to go, oh, this is not that organized. This is just the raw data. Let's make it a little bit more, readable, or organize it better, right? So you'll say, oh, I'm going to grab me some bowl here, right? And then say, oh, this first bowl is going to contain all the red colors. So I'll just dump in all the red into that bowl, right? And then this second bowl is going to be containing all the orange colors, right? Okay, orange Skittles, and so forth. Okay, so bowls here, right, represents what we call in statistical term, right, are considered to be what we call bin or classes. Okay, class. Okay, so like garbage bin. You could, I used as a bowl in this example, but you could think of it as a garbage bin, right? Where you could actually dump in the category like red, orange, yellow, green, and so forth. Okay, and then once you dump everything into the according bowls, right? Then you would actually count those out. Oh, there were 23 of them, 23 reds in that bowl, right? And that's why you organize it. Oh, there are 23. Okay, and then this is how you will list them out in a table, organizing it. Okay, so far so good. Any question? Okay, the difference between this one and this one. What do you notice about this one right here? Okay, what will be the observational unit just by looking at this table here? Jordan.
Yeah.
What will be your observational unit?
Oh yeah, I'm listening. How many miles were completed via pogo stick?
You're almost there. So observation. You're good. Almost there. Observing a person who's on the pogo stick, right?
Yeah.
Right. So it's a person we're observing. What will be the variable? Noun. let me ask you, what will be the variable? That's the answer that you just answered. What will be the variable?
The left side. So O2.
No, you just answered.
My fault. Oh, the miles completed via pogo stick.
Very good. The distance, right? Distance covered by the person who was on the pogo stick, right? That will be the variable here, right? So the variable is a distance. Is that a numerical or categorical data?
Numerical.
Numerical data, very good, right? Because distance is covered by in miles in this case, right? Numerical mile, 0 to 2 miles, in 2 to 4 miles, 4 to 6 miles, 6 to 8 miles, and so forth, right? So this is called the numerical data frequency table, okay? There's a difference between it, okay? Numerical data is a bit harder than what we call the categorical, right? Why? Okay, because categorical is, you could distinguish between each different category. We have red, we have orange, we have yellow, we have green and purple, right? This green is not going to go into this red right here, right? It's not going to go into that bowl unless you're colorblind, right? Okay, right? It's not going to go into that bowl. It is distinguishable, is right? Okay, numbers are not distinguishable. Okay, suppose I have something like this. Okay. Okay, so this is the pogo stick and this is the raw data. Suppose I have this raw data right here. Okay, there's a person who, right, travel 0.25 miles on their pogo stick. That will be me, right? My fat ass, right? I can't go anywhere, right? My kid could go on their pogo stick, right? Okay, on forever. They could go on for like 30 minutes straight without actually, you know, stopping. It's crazy, okay? My kid's like 10 years old. He's like, you know, 8 and 10 years old. They have the energy up the wazoo, basically, right? Okay. For some of you guys, you probably have, right? So here, what I do is, so here, you notice right here, this is considered to be what? Your categories, right? Okay, different bins, right? We have the red bins, orange bin, yellow bin, and so forth. Okay, numerical, this right here is considered to be a bin. Okay, so has a range in numbers. So what's your first bin? What's the first bin? Contains all the people that falls under what? The travel distance of between what and what miles? Raylene?
Would it be 0.15?
0 to 2 miles, right? 0 to 2 miles right there, right? Okay, so Victoria, what will be the second bin then?
0 to 4?
0 to 4 miles, right? And so forth, right? So therefore, where does this one go into? 0.25. Which bin does it go into? 1 or 2? 0.2 mile falls under the range of 0 to 2 miles. So therefore, it will be going on here, right? To that bin, right? So far, so good?
Yeah.
What about 1.75 miles? Where does that go into?
The same bin?
Same bin. Very good. Who said that?
Jordan.
Jordan. It will go into the same bin, 1.75. Very good. Okay, now, let's see, who should I pick on? Krista. Okay, all right. What about number 2? 2 miles. Where does that go in?
The first bin.
Is it first bin? Okay, Jasmine, do you have 2 miles? Where would this one go in? The first bin or the second bin?
Wouldn't it be the second bin?
Wouldn't it be the second bin? Okay, so there's a discrepancy here. You're like, you know, the 2 mile falls right between the first and the second, exactly halfway between, right? Where does it go in? you're like, it's not clearly defined as these right here, red, orange, right? Red goes into red, orange goes into red. That's distinguishable, right? Over here, when you see 2 right here, you're like, does it go in here or does it go in here? 0 to 2, it covers 0 to 2. 2 to 4, it covers 2, right? You're like, I'm confused. So therefore, to have what we call the universal rule for any statistician or scientist, right, that deals with statistics, they made a rule. They say when you have a bin width, this is considered to be bin width of 2 miles, okay? They always consider, they will always include the first number here, but exclude the 2. Include, exclude. Okay, so therefore, if you have that distinctive rule, where would the 2 go into?
Second bin.
The second bin. So the 2 will exactly fall under the second bin, because second bin includes the 2. First bin does not include it. Get the idea, right? Organizing, right? So if I ask you, where would 8 go into? I already did this right here. Where would 6 go into then?
6 and 8.
Where would 6 go into? 6 will go into between this one right here. 6 will go into that 6 and 8. Okay? You know for sure that does not go into this bin right here, 4 to 6. Okay? Get the idea. So now you have, right? So later on, you'll learn how to actually write this in interval notation. So when you write it, the bracket means to include, and parentheses means exclude. And that, okay? So first, so good. So your first bin width is gonna be 0 to 2, including 0, excluding 2. So far, so good? David, are you good? Okay, good. So far, so good. All right. So that's the frequency table here. Okay. So as the name implies, frequency table records often a categorical, right? These are especially used for categorical data, but we can use for numerical data as well. So okay, you could use for these are used for categorical, but often numerical category range value, right? So these are especially used for categorical data, but can be used for numerical data by creating a category from ranges of value. And that range, the first number is included, your second number is excluded on that range. Okay, so far so good. Okay, any question? Okay, so now here, so we have the what? So you guys know how to do the tally marks, right? Okay, so tally marks are very essential when collecting data so that it doesn't become messy, right? Majority of the, so who plays what here? What kind of sports do you guys all play here?
Football.
Football. Some of you guys play football, right? Some of you guys play what?
Wrestling.
Wrestling. And Victoria or Raylene?
Soccer.
Soccer too? Victoria?
Sorry, the internet cut out, so I didn't hear.
Oh, what kind of sports do you, what sports do you play?
Oh, I play softball.
Softball, right? So this will be good. So here, so if I ask, say, suppose that if there's a stadium of, students, right? Okay, there's 1,000 students, right? We ask all all the students in that stadium, which school you have to choose one or the other, UCLA or USC to transfer to and play for their school, right? They'll say, oh, okay, when we collect those data, right? You're like, oh, 1, 2, 3, 4, oh, 20, 45, 46. Oh, I lost count. And then you would have to actually recount it again, right? You don't want to be doing that. So you will just go, okay, tally marks here. And then after when you make the tally marks, right? Of course, I'm being biased here. Let's put some values in USC. Of course, some of your football players are like, I'm going to go to USC, right? And maybe not, I'm not sure. But get the idea, right? So you guys all went through the what? DICE applet as well, right? With your trainers before. Okay, let me confirm with Maddie and
I've
Ish.
done with them as a group. I don't know if they've went to an independent, like optional study session and done it. Have you guys done that?
Yeah, I did it with you and Joe.
Have you gone through I know we didn't do the applet for the DICE. Did anyone fiddle with that on their own or in a open tutoring?
Because my other groups, I had the trainers go through the applets with them as well, right? Go through the, I think you could watch the video as well as Professor Conley was actually doing it, right? How about you, Ish? Did you go through with your some of your group?
I believe so. I believe I did on Monday.
Okay, so if you haven't, you could actually have either Madison or Maddie and Ishmael to actually have them show you the applet, right? Okay, after this class here. Okay, all right. So that's that here. Let's look at here two-way table. Another way to actually organize your data. Okay, so two-way table here. Also known as a contingency table, is known for organizing variables that are multiple variable. In this case, a bivariate, right? So it's just two variable here, okay? The two variable here is gonna be, if you look at this, we have the age group, and the other variable is either they eat or skip breakfast. So far, so good. Any question on that? Okay, so here are the two variables, right? This is just one way to organize your data, right? And this is more complicated data considered to be bivariate. We only looked at, for now, up to now, only one variable here. But now we're looking at two variable. So here, you can notice that the 40 corresponds to student that's between ages of 10 and 13 that who ate what? Breakfast in the morning. Okay, I think the breakfast is the most important meal of the day, right? Who here actually eats breakfast in the morning, and who does not? Does everyone here eat breakfast in the morning? Yes or no? Yeah, some of you guys shaking your head, right? Who does not? Let's see who does not. Ish does, Ishmael? Victoria, Jordan, really? Wow, there's more people who does not. I think Jasmine didn't, right? Does not. Maybe half and half, right? Okay. So it seems like, yeah, half of you guys actually eat breakfast and half of you guys skip breakfast. Yeah, it's weird, right? And it doesn't run in the family either, right? My brother and I are like night and day. My brother never eats breakfast. I always eat breakfast. I think breakfast is my favorite meal. You get the pancake, you get the breakfast burrito, you get the waffles. So good. They're all sugary too. That's why I'm fat. So, yeah. So breakfast. So, but you could figure out. So in this case right here, we have what we call the row, right? Row total. Okay. Row total describes the what? The total for each age group. So how many students are between ages of 10 and 13?
54.
54 students, right? So how many students are ages of 14 and 17?
36.
36, right? How many students actually eat breakfast altogether?
52.
52. How many skip breakfast?
38.
38. And what is this right here?
The grand total.
The grand total.
Grand total. Grand total of what? Grand total of students that we survey, right? So there were 90 people who we surveyed between ages between 10 to 17 years old, right? And they grouped it into two different halves, right? So far, so good. Okay, and this is just another way to actually organize your data, a two-way table, right? To organize the data, okay? Of course, later on, you're gonna be learning how to actually figure out more information. If I ask you, right, what percent of students who are between ages of 14 and 17 who eats breakfast? Okay, as you can see, how many total students are in between ages of 14 and 17?
36.
36. Out of 36 students, how many eat breakfast?
12.
12 eat breakfast. So therefore, 12 out of what percentage of students between ages of 14 and 17 eat breakfast? 12 out of 36, which is 1/3, about 33.33%. So we could figure out more information, right? Right? So data is information, right? So we could figure out information about this right here, right? Okay, a lot of information. But this is basically what I want to kind of point out is the key thing is how to organize these data. Okay, so first, so again, let me erase this. I'm giving you all these different things here because this is a repeat. All right, so here, another way to organize data, right? This right here is the difference between what we call the categorical and numerical data, right? So here, a bar graph or bar chart, like histogram, bar chart use vertical columns to denote frequency. The big difference is the bar chart are only used for what? What do they use for? Only used for? Categorical.
Cool.
Categorical data, whereas histogram is only used for?
Numerical.
Numerical, very good. Okay, so just by looking at these two right here, okay, just by looking at the figure and the graph itself, what is another difference that you could point out? Just an obvious difference. It's not a trick question.
Between
David.
They have like gaps and no gaps.
Very good. So bar graph, bars do not touch. Okay, whereas histogram, you notice that they touch. Okay, that's the biggest difference between histogram and bar graph. Of course, one of the other bigger difference is that the bar graph is a categorical, right? Okay, organization and categorical data organization, whereas histogram is a numerical data organization. Okay, why is it in this form? And this is very important right here. Okay. This right here, we organize in pictorial form. Why pictorial? Why not organize it in just a table form that we just saw here? That's organized, right? And simple and readable. But someone finish my sentence for me. Picture is worth what? Pictures are worth Ish, help me out here.
Pictures are worth 1,000. I don't know.
1,000 words, right?
Yeah,
Very
1,000
good.
words.
That's 1,000 words, right? A pictures are worth 1,000 words, right? Just by looking at a picture, you could get so much out of it. Okay, so that's why we put it in a pictorial form, right? put it in a bar graph, histogram, okay? Later on, what we're gonna do is emphasize what the shape of the curve looks like, what the shape of the graph looks like. Is it symmetrical? Is it skewed to the left? Is it skewed to the right? Where is your measurement of the center? How is it spread out? And that's all done pictorially. And that's what the key features or characteristic that we're going to be looking at. So far, so good. One difference between what we call the numerical and categorical is that categorical here, our bar graph, right, okay, does not have okay. Can someone read that to me? Anyone?
Does not have inherent order.
It does not have inherent order, right? Your bar graph, does this bar of USA, does it have to be the first one there?
No.
You guys should all say yes, right? Because you are United States citizens, right? I'm just kidding, right? No is the correct answer. It does not, your USA does not have to be, you could actually interswitch this. You could get the UK to be the first bar here, and then United States to be the third bar there, right? You could interchange this. There's no inherent order of countries, right? One is not ranked over the other, right? We think we are, right? But we are not, right? Okay. So, but in here, order matters. There is an order here, okay? Numerical order, of course, numerical order is we always go in ascending order from 100, 100 to 150, 150 to 200, 200 to 250, and so forth, right? So your bar graph, if you graph it in different order, might not look like my bar graph, right? Right? But your histogram will always be exactly the same, okay? Long as your bin width is the same thing. Okay, so far so good. Okay, any question? Okay, another way to organize, okay, this is what we call the relative frequency bar graph, right? And histogram. This is what we call the relative frequency bar chart or bar graph. Okay, what is a relative frequency bar graph and bar chart? So let's actually go back to our table here. Let me kind of erase this right here. If I actually graph this, okay, this categorical, okay, bar charts are normally used for categorical data. If I graph this in a frequency, this is what we call the, I didn't do all of it. This is the frequency bar chart. Okay, frequency bar chart, you notice that we have what? Red has 23. So I increment this. This is the number of frequency. And these are Skittles. Okay, so we have the red Skittles. We have about 23, right? We have orange Skittles. We have 44 there. And you can see that that should be about 44 and so forth, right? Get the idea. And then I could keep going, and then I could start graphing all the, what, 5, is it 5? Yeah, 5 colors here, 5 category of colors, orange, yellow, green, purple, right? So far, so good. Now, how do you actually do a relative frequency? Okay, what is a relative frequency? Relative frequency is basically proportion or percentage. Percentage of what? Relative to what? Amir, what would you think? Relative to what? Amir, where are you?
Wait, say one more time.
Relative to what? So
Wait,
what am I? So relative frequency is a proportion. Relative to the, be that?
The total.
Total, relative to the total as a whole, relative to the whole. Right? So in order to actually figure out your relative frequency, right, what we need to do is figure out the total. What will be the total for this frequency? Can I actually ask you to add all these frequency here?
Yeah, sure.
Okay, let me give you a minute to do that.
Let me see the phone. Let me see the phone. Calculator. All right, 1 second.
I believe it comes out to be 149. Confirmation. Okay,
Yeah.
I think that comes out to be 149. So now, in order to figure out the relative frequency, right, for red, it's going to be 23 out of 149, which I already done here. So what will be your decimal form of your relative frequency? 0.154, or we could say 15.4%. So 15.4% of the bags are red. Of course, we could gone through the orange as well. This is like my chicken scratch over here. Sorry. Okay, so 44, there are 44 out of 149. It's approximately 0.295 or 29.5%. So 29.5% are oranges of that bag, right? And so forth. So what do I do? So rather than going through it as a frequency, we could do it as a percent. We go 10%, 20%. As you can see, these are the percentage. This is the category here. Red is about 15.4, so about 15.4 between here. Okay, and then we have the oranges is going to be close to 30%, 29.5% there. Okay, and then you could graph that bar graph. So far, so good. Any question? Okay, so that's just another way to organize your data in graphical form. So we have the bar graph and we have the relative frequency bar chart, right? Okay, and then histogram as well. Okay, all right, so let's look at pie chart. Okay, so pie charts are very common in practice. You see pie charts everywhere, right? And it's not necessarily a good thing, okay, when you're actually comparing two different charts, right? So let's try these questions here. In 2014, did company 2 or 3 have more market share? So in 2014, we had company 2 and company 2 and company 3. Which one had a bigger market share? Okay. Who had a bigger market share? Can you kind of definitively say?
Not really.
Someone want to guess? I could say, oh, looks like 3, right? 3 looks slightly bigger, right? But I can't be definitive, right? I can't be for sure, right? Okay, so far so good. I can be 100% sure that this is what? Definitive, right? It's hard. What about this one? Which company did better going from 2014 to 2015? So let's look at these two, right? Okay, company 1, did company 1 improve? Yes or no? Which is the red one?
Yes.
Yeah.
From here to here. Yeah, it looks like it, just by eyeballing it. What about blue? Did blue go from smaller to big? Did it improve?
Yeah,
it looks so.
Looks the same.
Yeah. Maybe it looks the same. It looks like it's slightly a little bit more here, bigger here. Right? What about 3? I think this one is a little bit bigger, right? It's kind of the same. I think it's shrunk a little bit. Yellow looks like it shrunk a little bit. Green, I mean black, is definitely shrunk, right? But it's hard to actually compare from one to the other, right? Now, if I ask you the same type of question using this, right? Okay, in 2014, which one did better? Company 2 or company 3?
Company 3.
Of course, company 3, right? It's so obvious with the bar graph, right? Okay, and so forth. We could actually tell if, you know, one thing has improved over the other. We could actually compare. Okay, so far so good. Okay, that doesn't mean, so we could say that, you know, some graph is much superior than the other, but that doesn't mean that the pie chart is useless. Okay, pie chart is used throughout. Okay, but when we do it as a whole, it makes much more sense. Okay, if you're not comparing from one to the other. Okay, and we need more information like percentages. If there's a percentage here, usually it comes with, you know, the category, the whatever that subject it is, right? It says company 3, and they give you the percent, like this is like 24% or something like that. They will write that down. Okay, then you'll be more, right? You should be able to actually compare those things. But by just looking at it, it's very, right, ambiguous in a way. It's hard to compare these two graphs here. Okay, all right. I think there's so much to do here. There's so much things that I couldn't cover. Of course, you should have gone through this on your own. Okay, so you should read this portion right here, which tells you why not to use the 3D graphing, because it is just unproportional, right? It just gives you a perspective that is not correct. Okay, so what we want to do is kind of go through. So Maddie and Ishmael will actually go through the rest of these right here. Okay, also the dot plot, another way to actually organize, right, your data. Okay, another form of organizing. This is for what we call the numerical data. Okay, and dot plot and your stem and leaf plot or stem plot, right, are used for organizing what we call the small set of data. Okay, and there are specific characteristics, right? Hopefully, Ishmael and Madison could actually cover these rest of this material here and then go through the problems here. Okay, so I'll leave it up to them to actually go through this right here. Okay, because I don't have any other further class to be. I'm gonna actually stick around, but I'm just gonna be listening, just listening. Don't get nervous, Madison or Ishmael, right? I won't judge you, right? But I'll be just listening, right? And I'll help you guys along. But I just need to do one other thing, right? Okay, so I'm gonna switch off to pass the baton to Madison as a host. Okay, she will be the host, and then Ishmael will be the co-host, and then she will actually pick up where I left off and answer all the problems there. Okay, so far so good. I'm gonna mute my. All right, have at it.
Hi, guys. Before we continue, do you have any questions about what Professor Yee just went over? About bar graphs, histograms, relative frequency?
Well, it's pretty straightforward, just organizing. Very much.
Awesome. Let me pull up that. What up?
Hi, Maddie. It's Angie.
Hi, Angie. How you doing?
All right. I don't see Amir in here.
Ish, I've removed him.
Okay. I appreciate it, Ish. I'll follow up. Okay. Thanks, guys. Sorry to interrupt.
Hi, Angie.
Bye.
All right, guys. Let me pull up those textbook chapter that Professor had up.
Madison, before we start, I don't have access to all 4 classes. What section is this?
This is 23.
23, okay, I have access to that.
You do?
Yeah.
Oh, cool. Awesome. Let me share my screen. Where did it go? Okay. So I'm not as fancy as Professor Yi. I can't write on the document. But I will do my best to help direct. So real quick, guys, what kind of graphs do you use for categorical data?
What? I stepped on it and it fell.
My family, I apologize. But someone shout it out.
Bar graph?
Bar graph. Conscious of.
Okay, good. That's one. What's the other one that you could use?
Pie chart?
Good job. You will get a spin. Thank you, Jasmine. I'm actually marked multiple spins for you guys throughout class because you guys were some of you were very responsive today, and I love it. We'll do it at the end of the session. But okay, and then what kind of graphs would you use for numerical data? Before we continue, I'm gonna see if you guys went through the module already.
Histogram.
Histogram, good. What's another option?
Stem and time plots?
Good. Good.
And what was the second one?
A stem plot.
Oh, stem plot. There you go.
Mhm.
Okay.
And you could also use a dot plot for either categorical or numerical. It's just dealer's choice on that one. But let me share my screen. All right. All right, so we went over the pie charts. All right. So these are just some other visual representations of data. Always be careful when you're looking at them in articles, other things on the internet. Truly understand what you're looking at. They can be very misleading, as the pie charts up here were. So just pay attention to that. And then we're going to go over dot plots. So you use dot plots when you're dealing with a single variable. So the example here is numbers of brothers and sisters. So it's not separating it into like how many brothers you have, how many sisters you have. It's just dealing with siblings in general. So that's why you can use a dot plot for a single variable. So then it's on a number line in chronological order. There's no vertical axis. It's just one number line. And then for every value that occurs, there's one, you add a dot. That's kind of a simple way to do it. And it could be used for both numerical and categorical data. And then you'll learn about this later on in other modules. But if the data is categorical, the shape of the data, of like how the shape the dots make after you plot them, will not have meaning. That only has meaning with numerical data. But we'll learn a little more about that later. And then stem plot. So this one is, or a stem and leaf plot. There's always a vertical axis, and it's kind of separating. So on the left side of the line, what value do you place there? Does someone know? No? Well, on the left side, it's every value but the last digit. So the example here shows 18 years old. So on the left side of the line, what number would you get? What number would you put? 1. Good. Yay. And then on the right side is always the last digit. So another example would be, so if you had 117, how would you put that in a stem and leaf plot? What would be on the left side of the line and what would be on the right side?
Last one is 7.
Okay, what would be on the left side?
11.
Good. And also with stem and leaf plots, they go from low to high when you're going from the top down. And then also when you're coming out horizontally from the line, like in the example that's on the screen, it goes 8, 8, 9, 0, 0, 1, 1, 2, 3, 3. It's from low to high. And also, the line can also represent a decimal point. I don't know if that example is on here. Oh, it is. For triple digit numbers and for 1 for decimals. The key allows anyone to be able to understand our data. So an example here at the bottom, the line represents a decimal point, so it'd be 4.5 hours of studying, or 4.3, 5.3 hours. It's just knowing your data and what the data is telling you, and reading what your observational unit is and what your variables are. Does that make sense? Yes. Hooray. Okay. Also, so looking at, can you guys see my cursor? I'm moving it around. We see it. So for the third line, for 3, what would be the sequence of numbers that I would have? If someone wants to type it in the chat or shout it out, just give me the full list of numbers for the third row.
30,
Okay.
another 30, 33, 34, and then 34.
Perfect. Anyone else have questions on that? It's pretty straightforward, right?
Oh, where'd you get 30? Where?
Because let me explain. Okay, you can explain. Sorry about that.
No, you're okay. Go ahead, David.
Because hold on, let me just move this in the way. When you look in the top part, how am I explaining this? So you look in the top part, it's like replacing the 2 numbers. Like for example, on the top, it says like on the top of the numbers, it represents the ages of the students in summer class. So in number 1, there's like 8. There's like on the first ones, there's 18, 18, and 19.
Oh, just find the numbers that go with that. Oh, I get it.
Yeah.
My fault, because I didn't see the top part. That's why. That's why I was like,
Yeah.
wait, where's he getting that from? All right.
So like in 30, it's like 30, 30, 33, 34, 34. Yeah.
34.
Hey, questions are okay. Thanks, David. I'm glad you were able to explain that really well. Okay, awesome. All right. So any questions about any of the other forms of graphs, tables, before we move on to the questions? Speak now or forever hold your peace. Okay. All right. So we're going to do just part A of this question. So look at the pie chart. Try to identify, you don't have to write it down, just for your own knowledge, what the observational unit is, what the variables are, variable or variables, and then answer question A. I'll give you guys a few minutes to do that. And I'll go around and get everyone's answers, what we think. If you have any questions, just shout them out if you're stuck. And Ish is going to call on someone to answer this question. And give them like 1 more minute, Ish, do you think?
Yeah, I'll give him 1 more minute.
1 more minute. Does everyone have an answer?
Are you guys ready? It's been a minute. I think I'm gonna call on Krista.
For part A, how many gallons a year does the average residence use for dishwashers?
I got 3,410.
Okay, and how did you get your answer?
So I multiplied 3.1 times the number of residents it says they have. And then I divided 3.1 times 100. 3.1, I divided that by 100 and then multiplied the amount of residents after.
Are you talking about the 110?
Yeah. Oh, yeah, the gallons.
Gallons. But your thought process was correct. So when we're going to do this, we don't multiply by 3.1.
Oh.
That is in percentage form. So we want to put it into decimal form. So we would move the decimal point how many spaces to the left?
It'd be 0.31.
Good. So you'd multiply that by what?
The gallons?
And then what would your answer?
0.031.
What was that, Professor Yee?
0.031.
Yes. Yes. So do that and then give us your answer, Krista.
I'm lost.
Who said that?
Jordan. I'm lost.
Okay.
I don't know how. So we moved the decimals to the left twice, and you get 0.031.
0.031.
Yes.
0.031. Yeah. And
Yeah.
you times that by the average residence yearly, or divide that.
You would
We'll
multiply.
multiply. Yeah.
Okay.
I got 3,410.
Good.
Yeah. Same.
Yeah, I got the same answer.
Perfect. I trust you.
Oh, that's how you do it. Okay.
Yep. I trust you. I just wanted to double check. Does this make more sense, Jordan, or you want me to go through it again?
No, it makes sense. So
Okay.
when you're trying to get the average of something, you gotta move the decimals and multiply the average of it. Yeah.
Well, because it's in percentage, so we need to move it into decimal form. So if it's just for practice, so if you're looking at the percentage of toilets, what would 28.4% be as a decimal? Jordan.
Sorry.
Just so I understand that you know like the concept. For toilets, it says it's 28.4%. What would that be in decimal form?
0.28, 0.284.
Good.
Right, because you're moving it. Yeah. Okay.
Yep. Good. Okay.
I had a quick question.
Yes.
So when do you use the equation where it's part over the whole equals percent over 100%?
You could use it. That's just making a proportion to find the part of the whole or to find the full percentage. And let me look at these questions. I don't think we use it in any of these questions. But an example would be if you're trying to find 20% of 30, That's when you would use the cross multiply part over whole x over 100.
Okay.
That answer your question?
Yeah.
Okay.
So what was the answer?
Krista, repeat your answer for part A.
Please.
It was 3,410.
Okay.
Oh, okay. See.
Did everyone get that answer or understand why they didn't get that answer?
Yeah.
Thumbs up.
I got it.
Can I get a reaction? Thumbs up from everyone. Sounds good.
Yay. Okay, now let's do part B. There's a few minutes to do that one. And Ish will call on someone different for this question.
Are you guys ready to answer? No? Okay. Give you another minute.
All right, Ish, give someone a cold call.
All right, David, can you answer the question for us, please?
I gotta be honest. I'm kind of stuck on this problem.
Okay. So how far did you get? We'll try to.
Like that's the thing. Like I'm trying to like figure it out. Like how do I even multiply or divide it? I don't even know.
Well, I can walk through this problem with you guys. So part B, if the dishwasher were to run every day, how many gallons per day does the dishwasher use? So if we look up here, it gives you the average yearly total of gallons used in the residence. That's for the whole year. So if we're trying to run every day, and we're trying to find the percentage of how many gallons are used for just the dishwasher, we need to break up to see how many gallons are used per day. So does anyone have an idea how we would find that out? No. So we would divide 110,000 gallons by 365. And that would give us the amount of gallons that are used each day. Does that make sense? Because
You
there's
said divide
365 days in
365,
the year.
right?
Sorry, David, say it again.
So you said divide 365?
Divide 110,000 gallons by 365. So you get your daily average gallons used each day.
I don't know. I got this right, but it says I calculated. It says 301.3.
Perfect. Awesome. So now that we have the average gallons used per day, now let's go back to the question. If the dishwasher were to run every day, how many gallons per day does the dishwasher use? So we have the percentage of the water usage for dishwashers, which is 3.1%. So what would we do next? It's very similar to the first one, the first part A.
So we just divide it again then, right?
We wouldn't divide, we would multiply.
Multiply. Okay. Divide. Oh no, divide. Multiply on 110,000.
No, we're looking at for a daily total.
Okay.
Because that's why we divided 110,000 by 365, correct? So we got
Yeah.
the 301.3 gallons per day. So we would multiply that, the 301, times 0.031. Does everyone agree? Can I get a thumbs up if we agree? Good. And then what would our answer be, David?
1 second. Still didn't get it right. It didn't calculate it right. It keeps telling me it's 0.9. That's not even it.
So we're multiplying 301.3
300.
times 0.031.
Wait, explain again. Sorry about that.
That's okay. So we have our daily total of gallons used on average, which would be 301.3 gallons.
0.3. Okay.
We would multiply that by the percentage in decimal form, which would be 0.031.
Okay.
And that would give us our answer. And what do you get?
0.031 is 9.34.
9.34 what? Don't forget your units.
Oh.
Chickens, Skittles, monkeys, what are they?
Gallons?
Yes.
Yeah, sorry
Good
about
job.
that.
Good job.
That's a lot. You can't have 9.34 monkeys. You
Yeah.
never-
Yeah.
Don't forget your units. Okay, let's do part C. Does everyone understand how we got the answer for part B?
I
Yes.
get the second part. I just didn't understand where you got 365 from.
That's
So
how many
there's-
days
I
in the
had
year.
an error.
So we're trying to
Oh.
find per
Like every
day,
day.
Oh, okay.
and then there's 365 days in a year.
So you
And what we
multiply. Oh, go on.
And they give us in the chart the yearly average, which is 110,000.
Mhm.
And we're trying to find out the daily usage of the dishwasher water.
Okay.
So we need to divide the yearly total by 365, because there's 365 days in a year, correct?
Yes.
To find how many gallons are used each day.
Okay. Oh, and that's where you got point zero
That's where
zero
we got the
three
301.
300. So 365 times or
110,000 divided by 365 will give you the
Okay.
average number of
300.
gallons used per day.
Okay, 301 point, and that's when you got 301 divided by 0.031, correct?
Multiplied.
Oh, you multiply it. Okay.
Yeah, it's the same kind of process as the first part. We're just adding an extra step.
And that's what we got. Oh, my,
Yep.
Okay, so 9.331.
Yep.
Okay. Gallons. Okay. All right, got it.
Okay, cool.
I was fine. I was like on track until you said like the year part, and I was like, oh.
That's all good. This is why we have this. All right. Let's do part C, making it just a little bit harder.
I give you guys a couple couple minutes to finish this because this one's pretty hard. You guys feel confident enough to answer right now? No?
And it's
I give
okay.
you-
Wrong answers and mistakes just means we will learn, and it's okay. No one is.
What's up? If you think you have the answer, can you just shout it out? Oh yeah. I don't know if this is right or wrong. I got 309.52. I don't know if that's wrong. No, it's wrong.
I didn't say it was wrong. I'm actually still working on it myself.
Oh.
I'm checking my answers.
Can anyone relate the answer to what Jordan got? No. No. Victoria, did you get answered? I couldn't hear you. Totally different. Yeah, Victoria got 15.97.
I got that too. Yeah.
I got 255.6.
Well, Madison still trying to work it out. We'll see what she gets.
Oh, well, we tried. Let's get another one.
Oh. Because I started this problem during lunch and didn't finish it. So I'm behind.
Really? You started at lunch?
I started it and then got distracted by my lunch
Oh, okay.
because it's lunch.
I don't know. Does do you have an answer for this one?
I do, but I want to just double check, but I can't find the answer key. Do you know where the answer key is ish on the?
Be on Canvas?
Yeah.
Let me check right now. Where to find it? And I guess he's not here.
He left.
Which one are you talking about?
Oh, there he is. Letter C.
You just verify what the answer is for me, please.
Letter C, which one? Each member of average household of 4 people takes shower every day for a year. How many gallons of water on average is used per shower? So, okay, so can you go up a little bit? Can I see the information there? Okay, so this is so we have average residence yearly shower, right? So I'm assuming that these are average of 4 people, right? Somewhere around there, household, right? So we have 110 gallons of water, and of that, bath, right? So what percent? 8.9% uses bath, right? A shower, 21 point. Okay, so therefore times 0.212. So therefore 233. So let me see if I can actually write on this. So we have 23,000. Sorry. Let's undo that. So 200. So let's do 2.
Hey, Paul, do you want to share your screen?
Excuse me?
He's writing on it. This is spooky.
Oh, he is?
Yeah. So this is the number of gallons that is used by the showers, right? That's the total number of gallons, right? So go back up again, see? I'll come back down, see? So if each member of an average household of 4 people take shower every day for a year, how many gallons of water is used per shower? So we could divide that by 4. Right? So each member of, okay. So each member of average household shower, so divide that by 4. So each member of an average household of 4 people showers every day for a year. How many gallons of water on average is used? Oh, used per shower. Okay, divide that by 4, divide by 365. Gives me, yeah, I get 15.97.
Yeah, that's what I got too.
0.97 gallons per shower. Okay.
Thanks, Paul.
Perfect. So there's 4 people. This is people. You're dividing by the people. This is gallons, right? And then this one right here, you're dividing. And then once you divided this, you're going to divide by 365 again. Question, Jordan?
Yeah, you got 23,320 by multiplying 110,000 by the...
So I got this one, so I'll show you. So 110,000 and then times 0.212.
There you
I
go.
think 21.2% will give you 23,000 320 gallons of a use, right?
Mm-hmm.
In a household. So we're going to divide that by 4 people. Divide that by 4 people. Okay, there's 4 people in the household, right?
Yeah. Mm-hmm.
So then we want to figure out each person's use per year. So this is per year, right? And then we get 23320 divided by 4, which gives me 5,830 gallons per person.
You divide that by a year, 365.
So this is per year. So this is per year. So therefore, per day, we want to divide by 3. So 5380. No, I'm sorry. Let me erase that. We have 5830 divided by 365 days. Then that will give you 15.97 approximately gallons per day per person.
Okay, I get it. I got it so confused. I don't know how I got 309. Sorry for my answer, y'all.
Well, who is this? Jordan? Is that Jordan?
Yeah.
So did you follow the step here? Because only 21% takes shower, right? So 21% of the whole 110 gallons of water that was spent is through the shower. So therefore, we figure out total number of gallons spent through the shower. Okay? Per year. This is per year, right?
Mm-hmm.
So therefore, and this is per household. So therefore, the household, if there's 4 people, then I'm going to divide that household, that use of, right? The total, that number of gallons, I'm going to divide by 4 people. Okay? So therefore, per year, each person uses 5,830 gallons here per person. Okay? Per year. Now we want to figure out per day per person.
360.
Yeah, and then divide that 5,830 divided by 365. Does that make sense?
Yeah, it makes perfect sense. I was doing a whole different route.
Okay, good.
Okay.
Thanks, Paul.
Thank you.
So we do nothing with the 4.
Another thing is that you have a capability right here. You could actually write if you're able to. Okay, if you have a pen, right? You should be able to kind of, when Maddie and Ishmael ask you guys a question, you guys could actually, whatever your train of thought, you could actually write those out.
Cool. I have no idea how he wrote on my own screen. That was spooky.
That was pretty crazy.
I was like, where did that come from? It's like magic. All right.
So you do nothing with the 4.
No. So after we multiply the total number of gallons used per year by the percentage used for showers, we divide that by 4 people because it says there's 4 people in a household.
Oh.
Does that make sense?
Okay, yeah.
I think what I did, instead of dividing by 4, I multiplied by 4, and that's how I got 255.6.
Does it make sense now why you have to divide?
Yeah.
Okay. Do you guys, we could go over the applets in StatCrunch, like the rolling die and the tally, since we didn't do that before. Let me stop sharing real quick. Fix this. So you'd open StatCrunch, and then go to Applets. And you go to experiments where you can roll die, flip coins, draw cards. There's also a spinner in there. The flip coin is cool because there's like, oh, I didn't share my sound, but it makes like cool sounds. Did you guys hear that or no? Oh, yes. It makes fun sounds. So you could do this for like ever and ever. So that's fun. Another one would be, Ish, where's the tally one?
I'm trying to find it, or trying to find something. I don't know where it's at. Sorry.
You roll a die. And this would always be, you're rolling a fair die. That will be important later. And it gives you the sum of your rolls at the bottom. Out of 2 rolls, your sum is 5. So that's fun. I like, just the noises are just really satisfying. And then you guys have seen the spinner. I've done the spinner with you guys for the MVP points. Whoa. Yeah, where is the tally?
I have no clue.
Oh, what? No.
It's not popping up on my StatCrunch.
Well, what we could do now, because I'll open up my spinner, and I do owe a bunch of you guys some spins. So, Ish, can you keep track of the points after I spin? Since I'm sharing my screen.
Yes, I can.
So you guys probably saw a glimpse and you weren't supposed to, but there were is for the number of spins that was during class, but we'll give more for your participation during this session as well. All right, Ish, who am I spinning for?
All right, I'm gonna leave you guys.
Okay. Bye,
Have a good afternoon, man.
Later, Paul.
Bye.
Appreciate it. Spinning for David.
3 points.
3. So you marked.
1 X is 1 spin.
Okay. And then Jordan.
5 points.
And then Jasmine.
2 points. Jasmine, I think you got 10 last time, right?
Yeah.
First day. I remember that one.
Just downhill from here. I'm just kidding.
Seriously. First time I feel like I won the lotto or something. And now it's like, okay, points. Like, okay.
Let's see. You give a spin for Victoria?
1 point.
Oh, she got 1. But it's okay. And so if you have 2 X's, what does that mean?
They get 2 spins.
Gotcha. And okay. Another spin for David?
1 point.
All right. Another spin for Jordan?
3.
I'll pick her.
And another one for Jasmine.
2.
All right, that's it.
Then I'm gonna give everyone a spin for being really responsive in this tutoring Zoom, because I love that. Thank you. But these spins were because they were participating in class, giving answers, being really active in class. So they were putting themselves out there during class, answering questions. So do that, and we'll always keep tally of it, and you'll get your spins, which are really awesome and important. But okay, so let's give.
Can we give Krista a spin? She answered a question.
Yes, I forgot about that one. Krista. 2. Who's left-ish?
I don't want to butcher her name. It's Raylene.
Yeah.
All right, and then oh yeah, she's the only one that didn't get a spin too.
And then Justin. 2.
All right.
Hooray. Okay. So that's
There's
fun.
also Victoria.
Do we do Victoria? Did we not do Victoria? Oh my god, I feel
Oh yeah,
so.
we did her once, so we can do it. We can give her another spin.
I feel bad. I can't even keep track of like my own anything. Victoria, 2. No one got 10 today. No one's lucky. The spinner does not like any of you today. No one got 10.
They're pretty good today.
It was pretty solid.
Spinner's,
You guys were really good.
Spinner's just a hater.
Before we go, because we only have like 8 minutes left, I have some just knowledge check questions that I wrote down during lecture today to see if you guys were paying attention. So, shout it out. Let me exit. So, what is a bin in a histogram? Can you describe what a bin is?
It's like the, how can I describe it? Like the categories on like for example, when he was showing like the variable on the left side and like all the numbers like in that category goes in that little bin, that area. I guess you could call it their little area. That's how I would describe it.
Okay. Anyone else have an idea? That was a good Jordan. Anyone else?
It's like to keep the things organized, like red, like the numbers, basically.
Okay, so that's for colors would be like how we used in lecture with Skittles. That'd be for like a categorical variable, right? What's an example of a bin for numerical data?
I would say dot plots or.
Well, there's no like there's no like specific like right answer in the situation. So an example would be range, right?
A range.
A range would fit in your bin. So the example that was in lecture, the bins were a width of 2. So it'd be 0 to 2, 2 to 4, and so on, right? Okay. And then, so if we have a bin, 2 sets of bins that the range is 5 to 10, and the next one is 10 to 15, where does the value 10 go? Which bin?
In the second.
5 to 10.
Same bin.
Good.
Same bin.
Good. And then, I don't know, Professor Yee called it the universal rule about bins. Was if, again, the example I just gave, so if it's 5 to 10 and then 10 to 15 and you have your value of 10, it always goes in the latter, the second one, the one with the bigger one in the range. Cool. Which type of graph needs to be in chronological order with your data and why? So if you're comparing like a bar graph and a histogram, because you use those for 2 different types of variables, right? You used a bar graph for categorical data and a histogram for numerical data. Which one needs to be in chronological order?
The histogram.
Why?
Because of the ranges of the numbers, you have to have them in order.
Okay. We haven't like learned it yet. It's in module 3, I believe, but it adds, because it creates the shape of the data and the distribution, which is very important for numerical data. For categorical data, it is somewhat irrelevant, the shape of it and the order of it. And then, good. And then how do we find the relative frequency? So if we have a frequency table and we have like the frequencies go from like 2, 7, 6, how do you find the relative frequency?
You add them all together.
Okay, and you get the sum. Then what do you do after that? If you're finding the percentage, right? So you would divide, it'd be part over the whole. So you would divide, good. I saw your chat, Victoria, good. So you would divide, so what did I say the first one was? 2? So it'd be 2 divided by the sum, then you'd get your decimal point or your percentage, that would be your relative frequency. Right? Yes? Understand? Cool. Ish, do you have anything? That was all my questions that I wrote down during lecture.
So, no, I don't have anything. I was gonna ask him how to describe a stem plot, but I think they know how.
Cool. Ooh, last one. So with a dot plot, how many variables are required for a dot plot, or do you need?
A single variable.
Good, David. Yay.
Nice.
We love this. Okay. Any questions before we go?
No.
Okay. And if you do, you guys can go to any open tutoring sessions that are on the schedule with any other tutors. They will gladly help you. They're all great. I know I'm the best because I'm your tutor. But but you guys can totally go to those. Make sure to watch the other recorded Zoom sessions. Let me double check to see when our next required class would be.
You guys did a really good job today.
You did. I'm so proud. So no required Zoom class tomorrow, but there are mandatory links to watch. There are multiple open tutorings, one with me at 1. I'll be there at 1. So come and I'll give you a spin with some questions. And then our next mandatory class, and there's this lab, would be on Friday. So look at your schedule, make sure we're there on time. Everyone was, for the most part, which is good. I am so proud. I am like a big punctuality person, like be here on time. I'm watching you. But yeah, go to open tutoring tomorrow. We'll get some spins, get some questions answered, and then get a jump on module 3 because it was posted, I believe, at 1 p.m. today. So get through that, turn all your stuff in. Anything else? We good?
I won't be here on Friday.
For what reason?
I have a family thing.
Okay. I'll make a note of it. Just, I hope everything's okay. Hope it's not a family emergency or anything. But let's not make it a habit, okay? So make sure to watch the recorded session after.
Okay.
From Friday. Okay. And then have any questions answered that following Monday in an open tutoring, okay?
Okay.
Thank you. Anything else? I'll see you guys all in open tutoring tomorrow at 1, maybe?
All right.
I'm just too pumped for all of you. It's okay. I just love stats.
Those extra spins.
If you guys come, I'll give you an extra spin, and maybe the spinner might like one of you and give you 10 points. I have no control over that. It's all up in the stars. The stat gods have all
the stat gods.
All right, guys. I will hopefully see you tomorrow, and if not, I'll see you on Friday for sure. Have a good day. Work on module 3.
Have a good one, guys. All right. You did a good job.
Thank you.
So you know stats like well?
Oh yeah. Yeah, I've let me think. I've taken so many stats classes. I took like intro to stats, obviously like in college. And then took another. I almost had a stat minor in undergrad.
Wow.
The class I needed my last semester, and I was not about to stay for another. But I did a lot of stats for my thesis in undergrad, and with my master's, I've taken quantitative and qualitative methods and econometrics.
Oh my God.
Yeah.
I try to stay away from stats.
Oh, I love it. Give me a stat system. Give me some data. Let me run it. Woo! I love that shit.
I took stats one time in high school. I failed.